Hi everyone, and welcome to the final session in this block from me. So through this block of teaching, we've explored different factors around resistance training. We've looked at strength training in general and how we program for strength training. We've also looked at speed and acceleration. And then in these last two sessions, we've been looking at agility. And in this one, obviously looking at how we train agility and change direction. So from this session, I want you to take away an understanding of the key areas for training for agility and change direction. And we'll also explore some of the different methods for actually improving agility and consideration as well. And so first off, just want to have a quick recap about the phases that are involved with any change of direction. Okay, it's important that we understand these different phases because each of these phases have slightly different characteristics, and obviously the demands on the body are going to be subtly different within each of these phases. So we initially have our braking phase or the deceleration phase. Okay, so that's where we have a high eccentric loading of the muscle as we are slowing down, obviously going into a braking. And then once we've completed that deceleration, okay, so we're in that transition phase or that planting phase as we transition from the deceleration out into the propulsive or re-acceleration phase. So whereas we've gone from that high eccentric component in the braking phase, we then have a high isometric component of strength in that transition phase or that planting phase. And then as we exit the change of direction, we go into this propulsive phase where we start to see the acceleration characteristics coming in. Okay, so we want a high rate of force development, slightly longer ground contact time compared to maybe max speed running, for example, but we want a high level of force application through the ground as we try and re-accelerate out of the turn. And now there are a number of technique considerations we need to think about when we're trying to develop agility and change of direction within an athlete. And what we're going to do here is we're going to explore both linear decelerations as well as some lateral change of direction as well, and some of the subtle differences across these movement patterns. But initially, for any agility movement, one of the things that we need to develop within the athlete is their ability to recognize visual cues. So remember, true agility is about responding to some form of external stimulus. And if, for example, that's a player, then the athlete will respond and try and recognize key movement patterns or cues from maybe shoulder positioning, hip positioning, and trunk positioning. Okay, that's typically where you're going to get the most visual cues. So whether that be responding to a tennis serve or a penalty kick, then trying to pick up on these key visual cues is really important. Now, obviously, that comes with a certain level of training and experience to recognize and pick out those key visual cues, but highlighting to an athlete that those are the key areas to focus on is a key start point for developing true agility. Now, when it comes to actually braking and decelerating, if we're looking at a linear deceleration, then we want to make sure we have a good control of the trunk. During the deceleration phase, we can see in this figure here, not too much of a forward lean, which is going to make the athlete carry on and continue the direction of travel longer than necessary. So good trunk control to decelerate. Strong flexion of the hip, knee, and ankle. Okay, with good eccentric strength, particularly through the calf and through the hamstrings. And then obviously we want a reorientation of the trunk into the direction of travel. Okay, so we might have just this linear position if we're doing a stop and then a reverse, or this might be the pre-turn step. So this might be the penultimate step, okay, before we start taking a lateral step with this in this instance to be the right leg, which will become the outside leg. Okay, so this penultimate step is where we see a lot of eccentric loading, as well as in the next step, but principally through most of the braking is done through this position here. So we need a good eccentric control, good trunk stability as well during any deceleration and change of direction. And then, as we've spoken about before, we see this outside step. We get an absorption of force application through the ground, but also then a propulsion as we re-accelerate, getting that reorientation of the trunk, center of mass slightly outside the base, okay, leaning back towards where we're traveling to, and then getting back into this accelerating position. And so during the re-acceleration phase, as we exit the change of direction, we want to make sure we've got this body lean. So again, that 45-degree angle that we've seen with our acceleration development. We want to have a good triple extension, so extension of the hip, the knee, and the ankle to get really good and effective and efficient force application through the ground. Okay, and we want to keep a relatively low center of mass as well. Okay, so we can see good acceleration mechanics in this picture here. Good triple extension. We've got good as well flexion in the hip, knee, and ankle in the recovering leg. Okay, good arm drive as well. Okay, really gonna impact the accelerating mechanics as well. So all of these factors really important for accelerating then out of any change of direction. And again, it's important to remember that the ground reaction force is going to differ somewhat depending on the scale of the turn. Okay, so the forces going through the body are going to differ significantly depending on the requirements of the change of direction. Also, those components are going to shift somewhat depending on if it's pre-planned movement or if it's a reactive, true agility change of direction. So we need to just consider this in terms of the loading. So obviously if there's a high braking force initially, there's going to be a much higher eccentric component to that movement pattern. So we need to factor that in when we think about the overall training load, because obviously when there's a high eccentric component, there's a high amount of muscular damage performed. So we need to factor that in when we're thinking about the overall load that an individual would undertake during the session. But then also factor it in with the amount of recovery required both between sets, reps, and also actual exercise training sessions. So we just need to be aware that the difficulty of the change direction is going to impact the scale of force being absorbed into the body. And again, just to recap, we can see that there's a significant impact from the change of direction scale, okay, and the amount of braking required. So the greater the angle of directional change, so once it's over 60 degrees, we're going to see a substantial increase in the braking requirements, therefore a much greater eccentric demand with an increase in change of direction. Okay, and so those penultimate steps, or the penultimate foot contact, is going to see a significantly greater overall braking and therefore eccentric force compared to some of the smaller changes of direction. Obviously, there still will be some eccentric force going through the body, particularly in this sort of 45 to 60 degree range of change of direction, but we'll see a much smaller eccentric component when we're in 45 degrees or less. Okay, so again, it's just to highlight what maybe training requirements would be needed depending on the scale of change of direction that's normally needed within a game or a sport, and also then impacting the loading that would be applied for the individual. Okay, a higher eccentric component, remember, a higher scale of damage likely to happen, higher overall requirements, and therefore greater recovery is going to be needed both within a session and between sessions. And so, as we've spoken about before, leg strength plays a key role in an individual's ability to change direction, in particular eccentric strength and isometric strength, okay, as we spoke about in the previous session. So whilst dynamic strength, concentric strength still play a big role, as does power, the main or the predominant factors in terms of strength that influence someone's ability to change direction is their eccentric strength and their isometric strength. So remember that components of the break-in phase of a change of direction and that stance phase in between the break-in and the propulsion phase. And so when we actually look at the impact that strength training can have on change of direction, if we look at this study here, we can see that they performed 8 weeks of supplementary strength training to their normal training program with relatively high levels of intensity, so 70% 1RM up to 90% 1RM, relatively high amount of overall volume, and training twice a week doing this strength training. And you can see that in the experimental group there is a significant impact on overall agility time. So we see a reduction in agility time for the 180 degree turn, for the sprint backward and forward running, as well as shuttle run times as well. So whilst it's probably influencing acceleration capabilities within these individuals, we're also probably seeing an increased ability to cope with the eccentric and isometric loads that's going through the body as they turn. So this squat program obviously has a relatively high eccentric component in the movement patterns, and having that high eccentric loading with relatively high intensity is going to facilitate the individual's ability to deal with the braking load that's going through their lower body. Okay, so an increased capacity to brake and absorb that load, okay, is going to increase the speed at which they can decelerate. There's obviously going to be a higher isometric force ability as well, so the ability to maintain in that stance phase, maintain body position as well. And then obviously that increased strength just as a base is also going to facilitate the application of force in that acceleration phase. So just with a relatively simple exercise, okay, just utilizing the squat, granted with relatively high intensity, relatively high overall volume, but it can have a significant impact on both sprint and agility performance within athletes. And another training method which can also be utilized for agility and change direction is plyometric training. Obviously with plyometrics we are utilizing the stretch shorten cycle, and the ability to absorb force is a key component of any plyometric training. So we can see from this COD study that when a group of athletes utilize plyometric training, there was a significant decrease in their measures of agility and changes of direction. So we see that both the agility t-test came down in the plyometric group, as well as the time in the Illinois agility run. Okay, high component of maneuverability within that test as well. So the plyometric characteristics that we develop, so that ability to absorb force upon landing, which has a high eccentric component again, and then that ability to develop that reactive strength that we know is so important for change of direction, particularly through that re-acceleration phase, can combine to significantly improve overall agility and change direction capabilities. And we can see that in a relatively short amount of time from this study that was taking place, we saw significant changes in their agility time. So 8% changes for agility t-test and a 7% change in the Illinois agility test. So quite significant changes in overall performance, which if you translate to the actual sporting domain, obviously we're going to see that any change of 7 to 8% can have a rather large impact on overall sport performance. So by utilizing the plyometric characteristics, where we have this high eccentric loading and a high reactive strength component, okay, can combine to improve our deceleration capabilities as well as our acceleration capabilities as we exit the change of direction. Now, another form of training that can be utilized to develop change of direction is neuromuscular training as a whole. So in this study, they performed a number of drills regularly with this neuromuscular training group compared to a control group, and they explored the impact over a season that this can have on reaction time and movement time during an agility test. And what we can see from the highlighted data is there was significant improvement in agility time, and this was borne out from a decrease in movement time, whilst there was no significant difference in reaction time pre and post intervention. And so what this actually represents is that whilst with the neuromuscular training group, they still maintained, well, there was a slight decrease in reaction time, but minimal, and had no real significant impact. What did have an impact on their agility times and change direction times is the actual movement time that was utilized during any agility test. So they activated at the same time point, but the actual responses were far greater in that neuromuscular training group. So they were able to get a greater overall activation and therefore greater rates of force development, and therefore decreasing the overall movement time during this change of direction. So by employing different drills that would develop this neuromuscular system in combination, we can see that whilst the actual speed of reaction to initiate the movement might not change, the level of activation and therefore the rate of force development would significantly improve, thereby reducing the overall movement time. And so another factor we need to think about as well, is something we've spoken about before, is the importance of acceleration for change of direction. Okay, we know that the braking phase is really important. The eccentric loading in order to brake efficiently is a really important element of any change of direction, but the ability to accelerate or re-accelerate out of that change of direction is also really important. So if we're just going to have a recap again and highlight some of the key components related to acceleration training. So we know that for developing acceleration, we typically would use quite light to no resistance, relatively low amount of volume of work, with a strong focus on high speed movements and focusing on this stretch shorten cycle. So whilst for acceleration we might have slightly longer ground contact times, we still want to really develop this rate of force development, and that's where we're going to see the greatest improvements. Again, we need to remember that for any speed or acceleration based training, it should be high intensity. Okay, the focus is on high speed movements, which even with no resistance or little resistance can still be extremely high intensity. So with that high intensity, we also would have then high amounts of muscle damage, and with greater amounts of muscle damage, then we need greater amounts of recovery, both within a session and between sessions. Okay, because the greater intensity is being done, the greater the damage. And typically the greater eccentric work that's being performed, which would occur during any acceleration based or any work that's focusing on this stretch shorten cycle within the muscle, that high eccentric component is going to lead to overall greater damage in the muscle. So therefore we'd have greater amount of DOMs, okay, so we'd have greater impact on subsequent training sessions. So we want to ensure that in order to maximize the benefit of any acceleration training or speed training, that we are doing it when the athlete is well rested and is able to put full effort in. Okay, so we don't want to be doing this when there's any significant or major amounts of fatigue within the muscle. So it's going to lead to even more damage and potentially injury. And so one of the ways that we can develop our acceleration capabilities is by providing some form of load or some sort of resistance for the athlete to sprint against. Okay, if we remember as well that by having some resistance, typically this would push us in the position that is most suited towards acceleration. So we'd have that forward lean around about 45-degree angle, making sure that we're focusing on that full triple extension through the hip, the knee and the ankle, and having good knee drive with the opposite leg that also has good hip, knee and ankle flexion, okay, with good arm drive. And so when we start to add resistance by the use of things like parachutes or sleds or bands, then typically this would start to increase the overall ground contact time. So we end up with a slightly higher overall force being developed during that ground contact time, which again is strongly linked to acceleration characteristics. So if we remember back to our speed and acceleration sessions, acceleration is characterized by slightly longer ground contact times, therefore slightly greater absolute force. Okay, because we have that slightly longer time period with which to exert it. So by using some form of resistance, we can better match the mechanics that you get for acceleration, and also the kinetics in terms of slightly longer ground contact times and slightly higher absolute forces, helping us to develop that reactive strength, which is so important for accelerating, which we know as well, really important for agility and change direction. There's also a number of different types of drills that we can focus on in terms of decelerating. Okay, so alongside developing our eccentric strength through resistance training, whether that be just greater focus on the eccentric component within a movement, particularly things like squatting or split squats, for example. We can also do lots of drills that focus on deceleration as well. So here we see the forward back deceleration. So we see the athlete coming in, hitting the line as they decelerate, taking a penultimate step to decelerate, with then their final stance phase step, where they fully absorb the force, and then going into the propulsive phase to either reverse or just hold that position. Now, there's a number of ways that you can actually apply this drill. So initially you could utilize just a mark on the ground so that the movement is somewhat pre-planned. Okay, trying to get the athlete to run as fast as possible to their predetermined break point, given a very short distance for decelerating and braking. Okay, and then either going into a reverse run or just holding that position. Now, as we can actually develop, okay, as the athlete gets better at decelerating, gets better control, you can actually start incorporating a cognitive component. So you could get them to sprint, and they might know that there is going to be a call within a particular range, but they might not know exactly when that call is to decelerate. Okay, starting to add in some cognitive / perceptual components. Now, if you want to extend that even more, you can start to incorporate an opponent and maybe reacting to an opponent's movements. okay, for these breaking drills, just to further enhance that cognitive component of the drill. Now, similarly, you can do the same for a lateral deceleration drill, okay, as you can see in the bottom here on the right. So utilizing again either a set point for them to start to turn, or they turn at a point, so they can know the positions they need to be in at particular points. Or you can start to factor in a call-based response, so they have to respond to a call by the coach, or again, increasing the level of difficulty, actually responding to an opponent. So typically for lateral drills, you would get them maybe to shadow an opponent so that they can match their movement patterns. So it's just different ways that we can develop deceleration capabilities, and therefore obviously increasing the difficulty of the task for the athlete. So in terms of progressions, okay, there's a number of different ways of progressing the training. So you might go from initially some technical training, okay, working on acceleration, deceleration, some change of direction drills, lateral shuffle, also getting used to back pedal as well. So we can focus on those components. We can then move on to more pattern running. Okay, so there's more of a closed drill over prearranged distances. So using some change of direction sprints, lateral shuffling, back pedaling movements again. And then we can also get a further extension where we get this reactive agility training. So these are much more open skills, and where you would get much more competition involved. So typically you would get the athlete responding to another athlete. Okay, and that might be some form of mirroring or shadowing, or some form of dodging or kind of tag activities. So trying to evade the opponent. Okay, better trying to reflect the demands of the sport. Now, as we develop an athlete, okay, initially there's going to be relatively low contextual interference. So for the more novice athlete, the big focus is going to be on the technical skill development. Okay, focusing maybe on one movement during each drill, so that we build up each of these components of the task, okay, before putting them all together. Okay, so at the lower end of the skill spectrum, we have much lower contextual interference, keeping it very simple and focusing on those individual components within any change of direction. As you then get to more moderately skilled, you start to incorporate a slightly higher level of contextual interference. So there might be greater amount of pattern running being used. There might be 2 to 3 movements used during a single drill. So just increasing that complexity as the athlete develops. And then once they become expert or highly skilled, then we'll start to introduce a relatively high level of contextual interference. So we start to get much more reactive agility training. So there's not only pattern running involved with pretty much all of the movements associated with a particular movement pattern within a sport, and also greater inclusion of the reactive element. So reacting to an external stimuli, and in particular reacting to an opponent or another athlete. Now, if we actually look at how we might differ training for different requirements based on different athlete levels, we can see here that there will be a slight variation of the type of training we might use, whether we're looking in the weight room or on the field, or whether we're looking at a novice athlete or an advanced athlete. So if we're looking to develop dynamic strength for the novice athlete, the big focus on body weight exercises, just going through kind of simple fundamental movement patterns. Whereas for the advanced athlete, there would be a focus on squat movement patterns and lots of pull variations as well. So again, making sure we're focusing on that hip, knee and ankle movement patterns. For the field work, there'll be a lot more body awareness drills, making sure they're getting into the right positions during any change of direction, whereas be a more variety of change of direction on the field for the advanced athlete. Now for the concentric explosive strength, the novice athlete be working more on box jumps, whereas whilst the advanced athlete be developing box jumps, they'd also be doing a greater amount of work on things like Olympic lifting. Okay, both box jumps and Olympic lifts have a focus on the triple extension of the hip, knee, and ankle, which is so important for this kind of acceleration focus that we'll be looking at. So whilst the novice would be looking at acceleration drills, again, no resistance, the advanced athlete would be using some form of resistance training in their sprint work as well. So using either sled pulls or sled pushes or parachutes, again, making sure that they get into that acceleration position. Obviously, for developing eccentric strength, which is a key factor in absorbing the force that occurs with deceleration, for a novice athlete, they would be incorporating more drop landing as well as some deceleration drills on the field. And for the advanced athlete, again, focus on these drop landings, but probably from a greater height, okay, and a much greater focus on that eccentric training. And again, with the field, a lot higher velocity being used in these deceleration drills and a higher variety of angles being used. To develop reactive strength, this is where plyometrics are really important. Obviously, we just develop the complexity that would be occurring as the level of the athlete increases. We also need to develop multi-directional strength if we're thinking about the lateral change of direction. Movement patterns like lunges are really important, so to develop as a novice athlete. But then as we get into more advanced levels, a lot of great focus on unilateral lifts and also greater amounts of degrees of freedom in terms of the variety of movement. So incorporating things like landmines, a lot more would give a much wider scope of multi-directional strength. Now for change of direction, there would be a lower general velocity in any change of direction drills in the novice athletes compared to the advanced athletes. And then finally, when we're looking at the perceptual cognitive components, the novice athlete will have a lot simpler reaction drills, so just either a temporal uncertainty or a spatial uncertainty in those initial phases. And then obviously as they get more advanced in their capabilities, that's when you get a combination or universal uncertainty incorporated. And you may even cause some restriction in the temporal or spatial components. So some limitation within the drill so that there's a greater focus on other factors that influence the reactive element. Okay, so here we can just see how whilst we might be moving or working the athlete in a particular movement pattern, okay, as we advance the athlete, the difficulty in those movement patterns, maybe the loading in those movement patterns can become more complex as the capabilities of the athlete improves. And so if we look at a simple approach to agility progressions, we can see on the slides here that those that are more novice are going to have much simpler movement patterns to incorporate within any change of direction drill. So initially we might get an athlete just to do one or maybe even just two change directions, or just a simple pre-planned change of direction. Then they might start to incorporate more than one change of direction, okay, but still keeping it relatively simple, keeping it pre-planned and keeping the overall movements relatively simple. Then as they start to develop even more, we'd incorporate a greater variety in the types of change of direction. So not keeping the degrees of the change of direction stable, increasing and decreasing them so that we get tighter turns. So you can see in this figure here, getting almost 180 degree turns at each point. Then as they start to develop, they get greater amounts of experience, we can increase that complexity, incorporating things like mirror drills, and then going into even more complexity with shadow drills, okay, where there's much more degrees of freedom of movement. Okay, so we're using a wider space. The possibilities for the movement patterns that can be used here are much greater. Okay, so we can see that as we increase the level of the athlete, we should be increasing the number of options, the possible outcomes, and possible changes of direction and scale of change of direction that is possible within any drill. So whilst we've looked at different ways in which we can develop agility and some of the characteristics that feed into our ability to perform either agility movements or change of direction movements, it's also important to look at other ways that we can actually monitor agility development. So we can look at things like change of direction deficit, so the difference in time between a straight line sprint and a change of direction test. So if we know a 10-meter sprint time, for example, and the overall distance covered in a change of direction test is 10 meters, we can then know what the deficit is in terms of the additional amount of time that's required for that change of direction. Okay, we know there is a link between straight line sprint speed and change of direction speed to some extent, but this is principally in the entry and exit of that change of direction. Okay, so we need to know how much decelerating and reaccelerating, how much time that's taking for the athlete. You can also measure things like ground contact time, similar to when we looked at acceleration and maximum speed. And so we can use this measure to see whether the athlete is effectively improving their force development and rate of force development in any change of direction test. We can also look at exit velocity, so the velocity during that initial step as the athlete is re-accelerating after they've pushed off. And this can give us an idea about, again, this rate of force development during this change of direction task. So if we see improved exit velocity in conjunction with a reduction in ground contact times, we're going to see then an improvement in overall rate of force development in that athlete. Can also measure entry velocity. So again, this can give us an idea of the speed at which someone is entering into the change of direction, so either that last step or the last several steps before that change of direction. And again, it will help you understand, or the athlete better understand, the demands placed on the body during that change of direction, and give a better insight into the relevance of the actual exit velocity that we're seeing in that individual. And then finally, we can have a look at decision-making time. Okay, so we can look at how long it's taken for a stimuli to be received and responded to. Okay, and so there we're getting an idea of where any delays might be coming from. Is it a delay in the decision-making or reaction time during an agility test, or is the delay, if they're particularly slow, for example, coming from the actual movement itself? Okay, so it's just another way of understanding then where maybe there is room for improvement within an athlete. Okay, if we're seeing particularly short decision-making times but then slow overall movements, we know it's both a mechanics and physiological factor, whereas if we're seeing a slow decision-making time but fast overall movement patterns in a change of direction test, for example, that's pre-planned, then we know that there's probably more of a cognitive component or decision-making component to the slower change direction agility times. Okay, so just to wrap up with some key take-home messages around training for change of direction and for agility. We know that a good change of direction ability and agility ability is dependent on the individual's capacity to brake and to then re-accelerate out of the turn. And we know that the ability to brake is linked to the eccentric strength of the athlete. We also know that if we then apply eccentric training and isometric training, coupled as well with use of plyometrics, then we'll see a significant improvement in both change of direction and agility capabilities. And additionally, if we incorporate acceleration training, which has a greater focus on the rate of force development, then again, that would lead to an improvement in overall change of direction capabilities and agility capabilities as well. Okay, so that brings this session to an end, and also this block of work that we've gone through, where we've looked at some of the responses to strength training, how we can then program for strength training. We've then looked at the characteristics around speed and acceleration, how we train for that. And then finally, we've looked at agility and change of direction and those characteristics that underpin agility and change of direction, as well as how we train for them as well. So hopefully you can see the link between all these different factors, okay, and hopefully you've seen that they can all kind of inform how we can prescribe training. As always, if you do have any questions, feel free to get in touch. Either drop me an email or feel free to book into my office hours. You can find details of that on Moodle, or again, feel free to email me if you're struggling to find any links there. And I'll be happy to chat through any questions you have. But until then, thank you very much for listening. Cheers.